Hello everyone. In this video I'm going to be giving you an overview of the A3 Laser Engraver sent to me by gearbest.com. Full disclosure, they did provide this laser engraver for this product review, product overview, so take that into account. I want to show you what this laser engraver is, what's included in the box, how to use it, and generally the differences between the different types of lasers like a CO2, a diode, and a fiber laser, and just kind of talk a little bit about the capabilities of each one of those and what they can and can't do. So let's first open up this box, see what's inside, and then start putting it together. Everything appears to be relatively well packed. The motors look like they've survived transit. This is actually relatively good packaging. So it looks like we've got the main power supply over here, the hardware right here. This actually looks really decent. I like the organization of this. That's quite nice. Got the stepper motors here in the middle. So I'm guessing 2 for the Y, 1 for the X. Pretty standard stuff. Laser goggles. These are actually pretty important because this thing is an open frame. It doesn't really have a full enclosure. I'm actually really glad that they included these because you could hurt your eyesight pretty quickly with something like this. A blue metal piece. Some of the laser cut acrylic pieces for the frame, I assume. Power cable, USB cable, belts. I got the actual aluminum frames over here, the little L brackets. These are just, I think, like a zinc kind of cast metal. So that is what that is. And then I'm guessing this is going to be all the electronics and whatnot. Yep, we've got the main driver board right there. This appears to be the actual laser module. So here is the actual laser module itself, and then probably a couple test pieces, I would assume, and then the cabling. The only instructions in here looks to be this piece of paper, which is just simply a package list, which is pretty much everything I just covered. Although there is a gift somewhere in here, not really sure what that is. So yeah, let me get all this unpacked, and then I guess we'll start trying to figure out how to put this together. Putting this kit together was mostly a pain in the ass, and it was mostly because there was no real instructions available. The packing list that you saw was the only thing that was included in the kit. There was no USB, there was no thumb drive, nothing else like that. So I had to go to GearBest website. They didn't have anything. Then I went to Google, Googled for the branded model of the engraver, and I actually did find a wiki with some assembly instructions, but there's a couple different models and none of them are exactly the one that I had. So I kind of had to just guess and check, also look on YouTube because there's a bunch of other people that are reviewing this engraver as well. And I kind of just had to piece it all together and figure it out. It's not a really difficult kit to put together, but the instructions I found were kind of misleading, and I still really am not sure what to do with some of the wires for cable management, and there's a couple extra screws and stuff that I'm not sure if I'm supposed to be using or if they're just extras. So overall, the assembly of this is not all that fun. If you like putting together kits and kind of like flying blind, then hey, this is the kit for you. But if you just kind of want to get the thing together and start using it, it's probably going to be a little frustrating because you're going to have to undo some things and rebuild it and just kind of figure out what screws you have and where they're going to go. It said use a 30 millimeter, the only thing I had was like a 25 millimeter. So it is a little bit frustrating because of that. So in terms of assembly, you basically start with the acrylic plates and you add the motors and then you add the rollers and you just kind of, start building those assemblies, and then you put in the aluminum extrusion, and then you put in the belt, and then you just kind of put the whole frame together. So once again, it's not really difficult to put together. You just kind of, got to figure out what they were thinking in terms of how it all goes together. However, I will mention that the one thing that is just not well done and was not fun at all was the belt tensioning mechanisms. I still don't realize why these cheap Chinese kits like this haven't figured out a good way to do belt tensioning. It's really not that hard of a problem. These come with these little acrylic cut pieces that you kind of feed the belt through, and then you put a screw through it with a lock nut, and it just kind of jams the belt down into the bottom of the aluminum channel, and then you're just supposed to clamp that piece down to the rail, stretch it out, and then that's your belt tensioning mechanism. However, acrylic really doesn't like to be under tension for very long, especially these small laser cut pieces like this. So eventually this piece is going to break because you're putting a lot of tension on it, or your belt's going to slip. So it's really just an inelegant solution that's not very good. For the same price, it could have been done much better. This was just a really cheap way out, I saw. Aside from the belt tensioner clip things, the fit and finish and the design on everything was, pretty decent. There was no obvious issues other than a couple little quirks that I'm going to get into later, but the aluminum rails were cut decently, the little corner brackets were decent, and all the holes on the laser cut pieces actually lined up just fine. I didn't have any issues with, trying to cram something in sideways because the hole wasn't lined up right. Everything really did fit. However, I haven't used this yet as I'm recording this audio, so eventually when I get to using it, I might change my mind on that. But as for right now, putting it together, everything seemed to go together the way it should have. Originally, I had planned to do more of a step-by-step assembly for this whole thing, but really that would have been an insanely long and very tedious video. So if you have any questions, just post down below in the comments, or just do what I do, is search YouTube and just look for some other people that have built one. I really don't think there's going to be a full step-by-step assembly with good audio. I found a couple Chinese ones that didn't have any narration, so you can just kind of look through the videos and kind of figure it out. Once again, it's really not that difficult, and quite frankly, I didn't want to put together a full assembly video for them for free because it would have been a really long and tedious video to put together. I've got this mostly together at this point. I left a couple things a little bit loose so I can go and kind of adjust them, but generally speaking, everything moves fine. This moves smoothly. This moves smoothly as well. I'm still not sure where all the cable management is going to go. I'll worry about that later. So let's talk a little bit about lasers. This uses a diode laser. Here is the actual laser module right here. It has a little focus ring on the end of it. There's three main types of lasers. There's basically a diode laser, then you have a CO2 laser. I'm pointing over there because that's where my CO2 laser is, and then you have a fiber laser. So at the end of the day, a diode laser is a lot like an LED. It's just basically a diode, like an LED, the D in diode. It's a diode that puts out a red dot. So this is very similar to like just a simple basic laser pointer that you would be accustomed to. Through technology advances recently, diode lasers have become significantly more powerful. This one is 2.5 watts. I think you can get this configuration up to like a 5.5 watts, something like that. Now this will be good for basic engraving, cutting some material, but we're talking like maybe felt, paper, cardboard, things like that. We'll see, but 2.5 watts really can't do a whole lot other than just kind of etch or engrave, and that's why this is called a laser engraver, not a laser cutter. Now for a CO2 laser, those things go anywhere from, let's say, 20 watts up to maybe a couple hundred watts. Mine is a 60-watt laser, and I can cut any organic material like acrylic, wood, cardboard, felt, leather, things like that, up to roughly around 3/8 or maybe a half an inch if you're lucky. Fiber lasers are a whole nother thing, and I'm not going to explain the technology behind them because I don't fully understand it, but fiber lasers use a completely different wavelength, so at a 20-watt rating, they can actually do metal etching and things like that. Fiber lasers are significantly more expensive, but have the right wavelength for metal. This diode laser and a CO2 laser will basically just bounce right off of metal because it's not the right wavelength to actually penetrate and etch down into the material. There are a lot of exceptions to what I'm saying here, but for the beginner or the introduction to lasers, the three main things you need to realize is a diode laser is going to be your least powerful and is just very good for engraving or doing like small cuts. A CO2 laser is going to be a lot bigger, a lot more complicated. This just runs off of 5 or 12 volts. A CO2 needs its own high voltage power supply, water cooling, a whole nother host of things. And then a fiber laser is going to be well out of your budget. I think they start around 50,000 or 100,000 and go up for there. So this is just going to be for basic engraving. So let's play around with the laser module a little bit. So here is the laser engraver with the module installed. A quick note about this. This little sled attachment is supposed to have these little thumb screws that allow you to adjust the height of a laser up and down. Unfortunately, the thumb screws are not long enough to actually press into this module effectively, so I had to use some actual screws on this side and adjust it with the Allen key separately. So you won't be able to use the thumb screws, or at least I wasn't. This was the first case in this whole product where the correct part just really wasn't correct. That being said, I've got my piece of test wood here that I use to test out lasers, and everything is hooked up. I've got the USB, and I have my safety goggles. These do come with the laser, which is absolutely necessary because this thing is kind of terrifying and has no safety on it whatsoever, and I'll show you that in a second. So whenever you have power applied to this machine, I would highly recommend you use the goggles. Now 2.5 watts might not seem like enough, but it is enough to cause damage to your eyeballs. So go ahead and make sure you have these on at all time. So I'm going to put these on and then turn this thing on. So there you go, it turns on. You can see a little dot pointer right there. The reason I am getting close to this is in just kind of the dot pointer mode. This is just for indication. This is not actually for cutting. Now this little button looks pretty cool. What if I press it? Oh, well, that turns on the laser on full power and just turns it on. So this is kind of weird to me. I think it's weird that I'm not actually connected up to any software on the computer. I have the driver loaded and it's recognized, but I'm not actually talking to any software right now, yet it's allowing me to just turn on this laser, which, is just kind of open in the air. If you had something reflective down here and you just hit that button, it could reflect off, hit your eyes, do all sorts of other stuff. So this is really weird to me. There's also no real e-stop other than just the main power button for this. So if you were just accidentally messing with this button, you could turn this on and go right to full power, which is really, really stupid. So this is a very unsafe product, just so you know. However, we did have a little bit of fun with this. Let's cut to that. I think we're still, yep. Science! So now hit the button. Turn it off.
I like it.
Of course you do. Every time. Yeah?
Yeah.
Huh. So that gives you a little bit of an idea of what a 2.5 watt laser can do. Granted, balloon popping is pretty easy, but that is 20 feet away or so. So if that hit your retina, think what that could do. So always make sure that you're wearing your glasses. So next step with this thing is to get the drivers installed, get the software installed, and actually start cutting some designs. The software side of this was actually a little bit easier than I thought. I'm here on the wiki page, and if you go down to the CAM software here, not only can you download the software and all the other stuff that comes with it, but you can also download the driver and it shows you how to install it. And really what it does, it just gives you this one exe file that is the installation. You just go through the installation, simple as that. And then you install the driver and then boom, you're done. And that's the software. So I've got the software over here. It is relatively basic, but pretty easy to use. So let's go over here and just kind of give a brief overview of what's going on. So here we can control the machine up, down, left, right, blah, blah. You're going to want to select the COM port that you're selected to and then hit refresh. I don't have the machine on right now just because it's noisy in the background, but you would just select COM19, hit refresh, and then down here in the G-code section it would say connected. Speed, you ultimately choose the speed based on what you're doing, whether it be a picture, text, or loading G-code. So this is kind of irrelevant. I think it's just for jogging the machine around. And then you can also set what your home coordinates is. This machine actually doesn't have any limit or home switches, so you just kind of move it somewhere in the middle, call that home, and there you go. So positioning is kind of a pain in the butt with this. If we go over to configure, you can reverse the X and the Y. You can also change the PLUSI. I think this is supposed to be pulse. This is, I think, once again, the speed. It's just the pulse at which the X and Y go. And then you also have the acceleration. This was originally set to 80, I think, was the original. I changed it. Didn't really seem to do a whole lot different, so whatever. Then we go down to settings. You can select the machine. Apparently, this software is set up for all sorts of different machines. So we just set it to laser mode, and that was successful. The other cool thing in here is where you can set the power of the laser and the power of the weak laser. The weak laser is just that little laser pointer. It was default set to 1, and if I clicked weak on, the laser pointer wouldn't come on. I had to set to like 50, and set at 50, that was enough that it actually showed on. So the default setting of 1 isn't powerful enough to even display the little pointer. I've been playing with this a little bit on and off, and I'll show you some cuts later. I think the laser will fire as low as like 200, but it really doesn't do anything. If the machine moves pretty much at all, it doesn't really cut or doesn't really do anything. So I've been kind of using this at 1,000, just full power, and then actually jogging the machine faster or slower to get a deeper or shallower cut. So we'll see. And then the gallery. I love the gallery. The gallery is all this lovely artwork. Most of it, I'm sure, is, completely copyrighted. We got the Avengers down there. It's actually spelled right, it looks like. And we've got an Iron Man up here. As you notice, if I scroll through this, this also zooms in and out at the same time, which is pretty amazing. We've got the Hulk, we've got Captain America, and all sorts of other stuff down here. And yeah, that was a test carve I was doing. So yeah, it's kind of interesting. So if we click on Picture Carve, I can select my logo here. And there you go. You can set the effect, which is basically how it separates black and white. If we go too much, it sees us all black. Too little, it kind of should go to all white. So you can, have a grayscale drawing and then select what the black and the white is. You've got your speed, you've got the overall size, you've got how many lines per millimeter, which is kind of weird. You can only go up to 20 lines per millimeter, which really isn't that great a resolution. And then you just click generate. You will most likely get some kind of error. You click continue, and there you go. There is your image, and you can kind of see the lines and the path that it's doing. If you want to do text, you can do the same thing by going into the text carve, type in your text, type in the size, same kind of deal. And then in theory, you could load your own G-code. What you're not seeing here is the ability to load a DXF or a line drawing or anything like that. I'm very used to taking things from SolidWorks, exporting them as a DXF or a DWG, and then importing them into my program and then cutting them like that. This is primarily for image and text engraving, so you're probably not going to be able to do any of that unless you take the DXF and convert it into a JPEG and then somehow print it out at a 1-to-1 scale. So there is that. Other things, preview is like the box command on my laser. It basically just moves the machine in the outer boundary of what you're cutting so you can see if you have enough space or if it's the right size, things like that. And then you can also manually turn on the laser and manually turn on the laser pointer. And of course, this is set up for 3D, and then you can just click this button to get it back. So, it's usable, it's decent, definitely very different than what most of the control software I'm used to using for like a CNC. But everything is kind of here. So let's just, plug in this logo, put in some material, and just kind of see what happens. The machine came with a few of these little test cards that you can print on. Wow, well, that just randomly turned on. I don't know why that just randomly turned on. That is amazing. So yeah, let me start this section over. I am now definitely wearing the goggles, even though I thought this was off. So I'm going to put this down. I'm going to try and kind of show you what it's like to center this up. So I'm going to turn on the weak laser. So I've got that. I currently have this set to the bottom left. So left bottom. So this is going to be my very bottom that I'm cutting at. And then if I hit that, what do they call it, preview, it should jog around. I mean, that's close enough. It should be kind of a little bit more like that. And you can see that it's kind of difficult to really line this up straight, but let's just call it close enough. So I'm currently using, let's see, 150 out of 1,000, so let's call that 15% power, and I'm moving at about 2,500 millimeters per minute. So yeah, that's about the max. I think this can do 3,000 as the max. So let's just give this a shot and see what happens. So I'm just going to go ahead and hit start. There we go. So it looks like it's engraving, and this will most likely be a time lapse because this thing will take forever. I did a test sample and it took nearly 15 minutes, but I sped up. So let's see what the time lapse looks like. And here is the finished engraving now that my whole shop smells like a campfire. So the first thing you might notice about this is it's a lot lighter in the middle than it is on the edges. And that's because the acceleration and deceleration of the machine, when it goes towards the edge, it decelerates, goes slower, and then accelerates once again. So it's spending a lot more time in the corners. The other thing that you can't really see is this all just kind of comes off and makes a terrible mess. So if you're actually engraving like a nice wood, all this dust and ash is just kind of embedded in there. Normally the way a laser would do engraving is it would have an air assist nozzle that would actually blow away this dust. But unfortunately what happens is when the laser hits the material, it just kind of vaporizes, and then all of that stays on there and you can't really get it out. So it just kind of embeds in the material and leaves it all nasty and ugly like that. So yeah, just not very effective. So yeah, I think I'm kind of done testing this out for now. If you've watched any number of my videos, you know that this is the part in the video where I talk about my impressions and my overall feelings on the project, things like that. And I've done this closer over a dozen times now. I've actually said that line probably a dozen times. And it always turns into just a rant of all the things that I fundamentally dislike about this machine. So I'm going to try and sum it up. Safety. It's lacking very basic safety feature. Software. It's lacking the I guess fundamental understanding of how a laser engraver really should work, you know, just going across the lines and things like that. It just really doesn't understand how a laser engraver should really function. Granted, you could use a different software, but that's a whole nother story. In addition to that, the features. This is missing any kind of air assist, any kind of ventilation, and those things are pretty critical, especially when engraving. Without the air assist, you end up just with this mess that you just can't really do anything with. I mean, sure, it looks like my logo, but it's just really inconsistent. If you get up close, you can see all the lines. Resolution. The resolution of this isn't very good, and I'm not really sure why. I didn't really talk about the electronics much. It's your very typical, just super cheap stepper motor drivers that just really aren't all that good, and just an Arduino. So maybe there's some, you know, hardware limitations to that. Other than that, fit and finish, you know, pretty standard for what this is. And just ultimately for the price, I mean, the price is perfectly fine, but maybe a laser cutter or laser engraver shouldn't be sub $200 or $200. Maybe you actually do need to spend more money to get it usable. So what I would recommend is don't get one of these. Don't get one of these cheap diode laser engravers. Yeah, I mean, they can cut some stuff and they can make, you know, little words, but I don't want to go into all the reasons why this is wrong. What I want to do is tell you to get a CO2 laser. Get a 35 watt or 40 watt, you know, K40 variant that you can get on eBay or Amazon any day of the week. You'll spend about $350. It's going to be more money than something like this, but it is a night and day difference. Trust me, it is very, very different and significantly better. So that's what I would recommend. But if you have any questions or comments, please let me know. I'd be glad to answer anything you want to know about lasers. And I'm actually thinking about doing a follow-up video to this where I explain a lot more about, you know, the deficiencies in this versus what a CO2 laser does or something like that. So anyway, hopefully you got something out of this video. Thank you for watching. You can always check me out on Facebook or check out my Patreon page to support my channel, or check out the other channels that I support. Thanks for watching. Turn it off.